I thought it
As long as it's not a bad word, I'm happy.
No, it wouldn't have been bad. I thought the French was a little bit more than a friend.
Oh, I see.
But given that I know very few words in several other languages, it's quite easy for me to infuriate my interrogators in no time. All right. Good morning, everybody, and someone just joined again. Yeah. Okay, good morning, everyone, and today is lesson 9, and reading the chat, it seems like there's something wrong with the content server, which is quite possible. So let's see what we can do to fix that. So just turn that off and then turn that annoying thing off.
We can actually upload the files via Zoom for the ones attending the meeting.
If we have to.
Yeah.
I've been having issues all weekend with that server. It seems to... Let's try it from the management window and see if we can get it to... See, someone's running a process on it, and it's not me. So I've been trying to regain control of it. Let's look for the last. So that clobbering is unexplained, and we're in decline again. So let's see if we can regain control. So plan B, Blackboard. I'm already signed in, so it's going to ask me to sign in again. Oh, sweet. Should have happened by now. Okay, here goes. Remote reboot. The remote reboot is amazingly fast, at least that's the illusion, but we'll wait a few seconds, see if we can reconnect. Wow. Going a different door. And I'll stall for a bit because of what I have to do next. So I will shut it down. And I'll lose 150 minutes of already paid for CPU time, but at least I'll get a chance to recontrol it. Perhaps y'all noticed over the weekend everything internet started working funny. So let's see, who are we going to blame this week? Do we blame the Russians or the Chinese or the North Koreans? Pick one of the three. It doesn't matter. It's probably explainable why just outright screw up, and there's nobody to blame. But being an election year, you can choose who you want to blame. See if we can do an audible. I don't think I saved a local copy of it. Farang, did you happen to download the two notebooks by any chance?
I have downloaded the ones for the lab.
But not the lecture.
No. Sorry.
All right. No, I didn't expect it to break. I mean, I had to reboot my computer 3 or 4 times and reboot my house router this morning a couple times just to get onto the internet. So there's something insidious going on. Let me see if I have. Yeah, I don't have copies here. So we're going to have.
Also, you don't have them on your hard drive?
Correct. I actually do them all remotely. And I didn't do a git push, so the only copies are sitting up here in Amazon. I'm going to let it idle for a minute. But while we do that, let's go ahead and we'll go through this PowerPoint file real fast, because this lesson was supposed to be the first lesson done entirely in a notebook. So naturally, oh, even my local machine's broken. With the dreaded spinning beach ball. So for you Windows users that don't deal with Macintosh, this is the equivalent of the hourglass or Shiva's drum bouncing back and forth. When this happens, the Macintosh is telling you to get up and go away and get some coffee, and in about 3 hours after it's attempted to access all your credit cards accounts, you might regain control of the machine. Well, we're really out of control. There we go. So this is one of those audible things. Oh, come on. What is your problem? Seriously? All right. Both screens dead. Oh, now we have a screen. So we'll go through this, and after I get done with this, like 10 slides, and there's almost nothing in it, because every slide says go to demo, go to demo, go to demo. And then I'll attempt to restart the remote server and see if that gives us the ability to finish today. And actually, the first thing I'll do when we do that is I'll grab a copy of the lab so that that's at least available. Okay, so Engineering 1330. Computational Thinking with Data Science. This is section 3 and 4 in fall of 2020. And today's stated topic is data display. I don't actually like that name. I don't think that describes what we're doing. A more professional sounding word is exploratory data analysis using graphics. So what data display means, or using graphics, is to take our data, let's say it's a data frame, and even if we do a head command on it, the head method, and it tells us what the rows and what the columns are, the first 5 of them, we can't see relationships in that. All we can see is that it has rows and columns in it. And before we go through an elaborate processing activity, we want to kind of look at the data to see if there's any point in doing that. For instance, if we have 2 columns of data and we're going to want to compare them, and we plot them against some common explanatory variable, and the 2 columns of data don't even come close to each other on a plot. I mean, there's a blob in one corner of the plot and a blob in another corner of the plot, and the blob is roughly horizontal. There's almost no information in that data as far as we're concerned, other than being able to tell that one column is different from the other column entirely in a classification sense. You can't do that by looking at the numbers in the columns or the items in the columns. That's where this exploratory graphical analysis comes in handy. Graphing is part of the Matplotlib library. Here it says Pandas library. Pandas library actually accesses Matplotlib library. And in some instances, it does allow us to make plots with quite a bit less effort than Matplotlib library. I don't think the Pandas features are as elegant, but they're good enough for most of what we might have to do. So our goal is to be able to visualize data using different types of charts and graphs. So if we were doing the Late Show with David Letterman, we would have been dependent on this for his charts and graphs skit that was common to that show, right just before Will It Float. Now, data are not necessarily numerical. We tend to think of that being the case, but data can also be images, either as in various file formats or actually images sitting in a shelf, a physical image that you are indexing. Data can be Music, again, paper music in a shelf that you're indexing, or music files, which is probably the more modern context of that. Data can be georeferenced attributes on a map, or actual places. Data can be polygons that lie on a map, and again, that georeferencing then becomes really important. It can also be categories of things into which you want to place certain items. So we'll start with that last context. So one type of data is called categorical. Cats versus dogs, and what we're doing is counting each. So if we're using my house as the universe of interest, we would want to count the number of cats in the house and the number of dogs, and those would be the two categories. And then the number in that instance represents the proportion of the house that's occupied by either of the two categories. So think of ice cream as another analog, because that's the one that I would hope to shell out and use. Go to the store and there's cartons of ice cream, but the categorical variable of interest is flavor. And we might be wanting to build a database to keep track of how much ice cream we have in the store, so that as people buy it, we can determine what the most popular ice cream is in terms of its sales rate, and what the oldest ice cream is in terms of how long it's been there on its long, sad journey to becoming freezer cheese. Another example would be professional basketball players. They constitute the items that are being counted, and the category could be the player's team. So that's what's meant by categorical distributions. Nico, really? Were you messing with the computer all day? Is that why it's broke? Did you type cat in it? Why don't you go lay down here on the couch? So we have a companion today. Oh, there you go. Good night. And one of the graphical tools we use to explore that type of categorical data is called the bar chart. So in this diagram, a bar chart is a chart where the height or the length of the bar is proportional to the count of the category of interest. And by default, the width in this drawing, the width of the bar is the same, and they're uniformly spaced across the graphics window. So if we have a bunch of things in there, each bar might be quite slender in order to represent the bunch of things. Up here at the top is called the title of the chart, and in professional practice, we're going to want to give that some meaningful title. So number of cartons is not entirely meaningful yet. And then down here at the bottom is the x-axis label, which is flavor. In this chart, y-axis label is either not specified or it's not rendering it. And one of the other ways that the items in the chart are identified is there's often a legend. And there might be a legend that has a little blue bar up here that says carton count. So what I'm going to try to do now is stop here and see if I can regain control of the content server. And then we're going to do some bar chart examples. So
I've been trying constantly, but still no luck.
No, I have it shut down right now, so you should have.
Oh, I see.
Okay, so once I go ahead and start this, don't anybody try anything until I can get the thing running. Because if it gets a lot of traffic, it might just be filtering at the Virginia hub. Okay, so we'll attempt to start the instance. And go to connect. And I'm intentionally going here So yeah, this is extra bonus class because we're doing cloud server management. And much as I would like to criticize my server vendor, on the whole, it's been pretty good. They must have detected that today was important, so it broke. And usually when it fails like this, it's usually my fault. Okay, so let's see if we can establish a connection. Yeah, sweet, okay. Okay, kill that. All right, I think we're in control again. Let's see, what else do I want to check? I will do the update later. That's what I was doing when it failed. So I'm scrolling back through my command history because I'm looking for a system control command. I don't want to go look it up. There we go. So your second computer class is going to be, you're going to learn all about this stuff. I'm kind of just kidding. All right, so we should have, I think there's actually a status. Let me see if status works. All right, so where's the error file? 13 seconds ago. Oh, that's probably why it's been clogging up a lot. I bet this task limit item is adjustable in the configuration file, and I've not done that. I'm using a sample default. All right, I believe it's working. Farang, can you go check? Go ahead and attempt to, don't go to the Jupyter Hub, just see if the website part's working.
It is working.
All right.
Yeah.
Exit the shell. And let's find my Blackboard. That's going to happen to you all more and more in your career. Okay, so there's the pseudo lesson. So I'm going to just go ahead and look at the notebook for now, and then we'll switch to the Python notebook. So in the lesson directory, there's all this stuff here. These are various examples. But lesson as a notebook is here. Visual display of data. And in this lesson, we want to introduce the Matplotlib external module package. You've seen it already. And examine how to construct line charts, scatter plots, bar charts, box plot, and histograms. So histograms is kind of a very fancy bar chart. And we're not going to go into any of the real theoretical aspects of it today. In fact, there's no lab on it. I'm just going to show you how to build a histogram kind of at the end of the lesson using, I think I'm going to do it in pandas. And then let's look about Matplotlib itself. So what we're using in the Matplot library is actually just a portion of it called the PyPlot API collection. And it's a collection of functions that make Matplotlib work like MATLAB. And each PyPlot function, I'm having trouble reading this, makes some change to a figure. And it creates the figure, creates the plotting area, decorates the plots, and so forth. And what it does that's nice is it maintains particular states across the function calls. So as you're building a figure, you don't have to recall certain aspects. And then once you render the figure, which is the plot plot show method, then where those states no longer be preserved is when they're released. So data are not always numerical. And there's the, I want to actually go one more place. A lot of this is coming right from here. So here's the matplotlib.org website. And if you read it, it has a user's guide, a development, and lots of information here. It also has a little search engine in it. So let's see how to work that. I want to do bar chart. I'm typing the word bar chart into the search engine, so it's going to search matplotlib.org for instances of that string. And this is what comes out of the search engine. Initially, it's like, oh crap, there's nothing there. I can't believe that. But really, it's just bringing back links to all the different things in bar chart. And then just for grins, if we go horizontal bar chart, it gives us a picture. And if that's what we're trying to produce, it even has an example. So a lot of the examples for this lesson are taken from either that matplotlib.org or in this case geeksforgeeks.org. Okay, so our first one is going to go with the ice cream paradigm. So this one is written and in Matplotlib library, and it's fairly generic. So let's say we have a data model, and looking at that, what type of data model is that? Ice cream is a dictionary. Good, excellent, Roger. It's a dictionary, and it's also a dessert. Yeah, okay, very good. And the way you identify a dictionary, first thing giveaway is curly brackets. That's a set builder notation. But the second giveaway is an item, a colon sign, and then another item where it's identifying the key and then the data item. It's also quite possible that you saw the lines below and saw the word key and values and realized dictionary. So there's our first step. Let's say we have that data model. For what it's worth, this would not be an efficient way to build a data model of any real data because of it's a difficult way to construct it. Nevertheless, okay, so we have this data model. Next thing we're going to do is we want to import our graphics. So here I'm doing import matplotlib.pyplot. So I'm taking the Python plotting library that's part of the matplot library. And that's all I'm getting from it. I'm not doing any as and giving it a name, and I'll regret that, but I wanted to do one illustration of fairly generic Python without taking advantage of renaming. In some sense, I would imagine in a commercial code that needs to be maintained, if I were doing this for money, I would actually probably stick with this. I would have these really long constructors so that I know what's actually going on in the structure. So we've imported the library. The name of the library is matplotlib.pyplot. So any function we access from that library will have to be prefixed with that path, matplotlib.pyplot. Whatever the function is. So now we're going to make two lists. First one is a list that we're going to call flavors, and it's just a list object that's based on the keys in the ice cream. So flavors is going to contain the string chocolate, strawberry, and vanilla. And then cartons is going to be a list based on the values in the dictionary, 16, 5, and 9. In this particular list building structure, we've implicitly assumed that there's a one-to-one association, meaning position 2 of ice cream dot values corresponds to position 2 of ice cream dot keys as far as plotting is concerned. Now we start to prepare our plot. We're going to create an object called myFigure. That object is going to come from a class called figure that's in the matplotlib.pyplot repository, and we're giving it an argument of figure size 10, 5, and that's pretty much just setting an aspect ratio. I haven't read deeply enough to know what the 10 and the 5 units are, if it's inches or centimeters or something, or if it's portions of a default graph window. But a 10 by 5 is going to produce a rectangle that's wider than it is tall, as we'll see below. I mean, it's right there in our face. Then we start to build the plot. So first, from Matplotlib pyplot, we want to construct a bar plot, and that's what's going to be stuffed into the myFigure object. We're going to plot flavors in cartons. We're going to make the plot maroon, and we have this optional specifier. We're going to make the width of each bar 0.4 units. Again, I don't know what the units are. On my screen, it must be bigger than inches, so I don't actually know what the units are. And I'm capable of rating as you are. If it really mattered, I could go and investigate that. The next thing we're going to add to the plot is we're going to decorate it by labeling the x-axis. And we're going to name it flavors. Then we're going to decorate the y-axis, name it cartons. And then we're going to decorate it by putting a title called current ice cream in storage. And then the money shot is we're going to render the plot. So when we type matplotlib pyplot.show, it's going to send the fully built plot to the graphics device. In our case, the graphics device is probably localhost on our browser window, but again, I haven't read deep enough to verify that. The browser software is the graphics device for our purposes. And boom, we have this picture. Now we can go try to do it live. Good thing I got Memorex running. And to go live, I go here. So let's try to do this. I'll try to do this live. For the time being, just follow along. Okay, that's good. Loading. Oh, looks like I was here already. So this is literally just a notebook. So this is the first lesson that I've attempted to do entirely in notebook, and my intent is all the remaining ones will be notebooks so that you can read them yourself after class and directly follow along and actually play in them. So I have an idea. Let's turn, I hope I don't regret this, let's turn the kernel off. Run all cells. There, that kills the notebook. Turn the kernel back on. It's loaded. So now we'll run them one at a time. So here's the same example that was in the HTML file. Create the object, import the library, a little bit of work to prepare the lists, and then we'll build the plot. So let's see what happens. Ta-da! I don't know how to make it make noise yet, but in the future I'll have it do that. So now let's just make a small change in the import statement, tidy up the script, get what's simpler to read for humans and arguably a more conventional approach. So the only change we're going to make is we're going to import the library matplotlib.pyplot as PLT. That's the name we're giving it, PLT. Everything else is the same. Now when we generate the my figure, we're using plt.figure instead of matplotlib.pyplot.figure. So there's certainly an economy of typing achieved. Build the bar plot, label the x-axis, label the y-axis, generate a title, render the plot. And we changed it to orange because we all like orange sherbet, which is not represented. And now, same bar chart. So let's deconstruct the script. Now, I've already discussed this, but this is important, in my opinion, to help you understand how to use other people's examples and build them to suit your needs. The first part of the code, we have the dictionary object. In this case, we've created it, but more likely, this will come from reading a data file, either as a data frame or into lists. Then we import the library, and then we generate the two lists. So generally, the plotting tools operate on lists. The things you're going to plot, to use the series metaphor from pandas, are lists. In some of the plot functions, you can send them data frames directly, and it knows what it's programmed to parse them apart for you. But just keep that in mind. Before you give up on an email and saying, I did just what you did and it didn't work, that would mean you didn't do just what I do. Check that you're sending lists to the plot call and they're in the right place. And then if that's not the case, then it may be hard to diagnose. So we have two lists, flavors and cartons. The lists themselves aren't very interesting. Flavors has chocolate, strawberry, vanilla. Cartons is 16, 5, and 9. The next statement is where we draw from the figure plot, the figure class in the plotting library, and create an instance called myFigure. And then myFigure, everything we do from the plotting library gets put into the myFigure object until we render that object. And then the object's preserved, but any new calls can either be sent to the old object, or if we create a new object, they'll send a new one. So the next portion, bar chart and X label, Y label, title. And then the last statement, which I've intentionally split off from everything else, is the rendering statement. This one, plot show, just sends the plot to the attached graphic device, which in our case is the browser. Let's see what happens if we add an additional category. So I've created a new dictionary object called eaters, and it comprised of the main animals that eat these ice cream: cats, dogs, and ferrets. And in this particular community, there's 6 cats, 5 dogs, and a very overrepresentation of ferrets, almost 20 of them. Probably inside a store called Ferret Gamos. And again, we're doing a lot of repetition. We don't really need to re-import Matplotlib, but to be precise, or if we wanted this to be portable, we'll just include everything. It won't break anything. So we re-import the library. We build the flavor lists. Now we're going to build an animals list and a beasts list. And sticking with the animal theme of Python, do stuff based on ice cream and animals. And again, we're going to generate a myFigure instance of the class figure object. Then we go through building the plot. And the only difference here is we have the original ice cream plot and then the new animal beast plot. So I did this because I want to see what happens. And then if we just go ahead and run it. And so part of the attractiveness of the Jupyter notebook and Python in general is, at least when you're doing development, you shouldn't be afraid to just try stuff. that makes some sense. So we're going to try to do two plot series, one after the other, and then show the plot and see what happens. What we're going to happen is we're going to get the first series will start from the left and work to the right, and the second series will take off where the first series ends, except when it doesn't work. T is. I must have edited something. There we go. And so here's the flavors and cartons, and then we get over here to beasts, to animals and beast count. So those two series don't make a lot of sense plotted next to each other in that way, but that's how we could plot multiple series on the same bar chart. Another thing we could explore is ways of having independent series that have the same category variables and kind of get the bars to part next to each other. And you've seen that a lot in a lot of televised and in various classes when they're trying to convince you of something that's not true. You put all the stuff next to each other and you go, see? But now let's suppose we want to plot this horizontally. We could make a guess, but that might take a while. Or we can use the pyplot.org search engine. And if you type horizontal bar chart, it comes up with several links. And if you take one of the links, the one I took gave this stuff. And I look down here and it's like, yeah, that's kind of how I want it to look. This is a stacked horizontal bar chart. The most important thing is that I was looking down in the dependencies because it reports dependencies. And there's this method called bar H. It's like bar, like bar chart, H for horizontal. Okay, cool, let's try that. So I return back to the original script, make a couple of changes. Change bar to bar H, bar to bar H, and in that case, width no longer makes sense because it's going to plot over the width of the entire thing anyway. And so I just took those out, and if we run this script, horizontal bar chart. So there's lots of other variations, and you all can read just like I can. So remember, Google, your friend, unless it's reaching into your credit card. Now let's going to do the same exercise, the same examples using pandas. So pandas, when it loads, accesses a portion of Matplotlib library by itself, and I don't want to attempt to demonstrate it, but I could demonstrate it on this server. If I uninstalled Matplotlib and then tried to import pandas, I'd get a error message saying Matplotlib is nowhere to be found from importing pandas. So here we'll import pandas as PD. And we create an object, myData. Again, it's using a dictionary construction process. So as of right now, myData is a dictionary. And we'll use the pandas data frame method to turn myData into a data frame. And we'll go take a look at the data frame. It's not terribly interesting, but we do that. We have flavor, number of cartons. We have the index column, item 0, item 1, item 2, and we have the columns' names and their contents. We could describe it. Remember from your pandas lesson, what's going to happen when I run the describe method? Anyone remember? I'll do it. Okay, where is that sound coming from? Strange sounds in my house. It compares values and things. Yeah, that's what it's used for. So the describe will probably generate some statistics. I don't think there's enough information for it to generate very effective statistics. But the flavor column, it's not going to tell us anything about that except possibly how many is in it. So all it does is statistics on the number of cartons. And we only have three records related to cartons. So I would be somewhat suspicious of the min to the max and the percentile ranges. Nonetheless, let me return it back to its original structure. And now let's go ahead and make a bar chart. So in the pandemonium world, the way we would construct a chart is the keyword plot. So that's a method that's part of pandas. And then we tell it what type of chart. So this method is part of pandas. So when it created the data frame class, it also created a method called plot. And the plot method has options, one of them being bar. And then we tell it what to plot on the x-axis of the bar chart, what to plot on the y-axis of the bar chart, what color to make it. And if you'll notice, the x-axis label and the y-axis label are the keys. And here it has the flavor labeled, and then it identifies the three categories, and then here's where it's using the legend to tell us what we're looking at. We also can rotate the labels. You might say, nah, I don't really like it looking like that. Do it again. We've rotated the labels 45 degrees. We can try 90. And it ignores me. Still ignores me. I'm tempted to try a 0 to get them horizontal, and sure enough, that works. So you've got the choice between horizontal and various angles. So here's horizontal, pi over 4. Pi. And if you don't specify rotation, it defaults, I'm pretty sure, to 90. We'll just look at another example. This is directly from Geeks for Geeks. This is their example. So it imports the necessary base, and then they created a dictionary that's the number of students in different programming language classes at some hypothetical school. And then it pulls out courses by data keys and values by data values. It generates a figure named Fig from the figure class in Matplotlib, and then builds the bar chart, and then provides the labels and renders the chart. If we do that, and so in this particular example, at wherever this school is, there's 35 students in the Python class, 30 in Java, 15 in C++, and 20 in C. This has got to be a computer science department. Just an example. Okay, our next type of chart is called a line chart. And a line chart or a line plot is a chart which displays information as a series of data points, and the points are referred to as markers, and they're connected by a straight line segment. That's the key concept of a line chart, and I'll show you what I mean in a minute. Line charts have lines connecting the points. Depending on application, those lines are connecting the points simply to guide your eye as you're moving from point to point. In other instances, the lines are thought to actually confer intermediate behavior. So usually a line chart is just trying to help you identify the progression of points. Line charts are similar to scatter plots. The main difference is that the measurement points are ordered, usually on the x-axis, meaning a scatter plot, when you build it, you can have an x value of 0, 23, 11, 2, 7 in that order, and it will just put the point where it's indicated by the xy coordinate. Whereas a line chart, it puts it in order. We'll modify this example here to show you what I mean by that. So let's consider this experimental data below, elapsed time and speed. And we've been asked to show the relationship between time and speed, decide if the relationship is indicating acceleration, and if so, how much. So let's create two lists. And so we've created one list called time, which corresponds to that column, one list called speed, which corresponds to that column. And we'll build a line chart. And there's our line chart. It's not a very interesting one. The axes aren't labeled, which would be 2 points off if you were taking this in my class. There's no title. That's another point, 3 points off. And the units aren't supplied in the axes for us. So 5 points out of a 6-point problem lost simply because we didn't decorate the lab. And they think, well, I'm going to get all my points. So we decorated and actually have included another option. So here is our line chart, and we've actually added a model. Let's look at the model. We've added a model where we calculate the average acceleration as the maximum speed minus the minimum speed divided by the maximum time minus the minimum time. So that's essentially the change in velocity with time. And then I built a plot title function and series name, and then model Y and model X are going to be the points associated with time and speed from these acceleration estimate. Farang showed you that back in pretty table days, how to plot a single point. And so here we're going to produce two plots, the actual observations and the model plot, and that's how we get the blue and red line on the same thing. But let's see what happens when I change the order of how the data is presented. So I've created a new cell, and now I'm going to start interchanging things. I'm going to put these guys right here, 2 and 3. I think that should correspond with these 7 and 12. Okay, so it's important. So the data is still in the correct proportion, 1-to-1. So a time of 3 corresponds to a speed of 12, and a time of 6 corresponds to a speed of 45.6. So there's no damage in the data, and I suppose I could do some simple statistics and prove that. In this case, I'm just going to ask you to take it on faith. But let's see what happens when we create a line chart. So maybe we'll get the same picture. I'm kind of thinking that might happen because I'm hoping that that's not the case. Change the marker. Somebody choose a color. Okay, I'll choose my favorite one. Not the color, I just love the name. Green, blue, blue. So we'll go ahead to something. We'll go for green. That way we have the red-green show. Okay, so same data, just some of the records are interchanged. And now it looks all fucked up. Okay, so what has happened is because the way a line chart builds is it plots the data in the right place, but it's joining between sequential points a guideline. So it's plotting this one, then this one, and so you get this loop, and it looks goofy, and yet the data is right. The reason is what we really want in that case is we want something called a scatter plot. And right here with this line width equal 1, I think in the scatter plot, oh, it still doesn't draw a line. That's what we wanted it to look like. And so the warning here is that line plots and scatter plots often are doing the same thing, but when the data are not ordered, the tool you're probably thinking of for an engineering application is a scatter plot. And we'll have to read on scatter plots because there should be ways to draw lines. Ooh, there's really ways to break stuff. What did I do? Oh, my bad. The generic word for line plot is plot. Okay, so let's go back and deconstruct this a little bit. So when we did this first plot, our first question is there evidence of acceleration? And that would be a yes, because acceleration, if there were zero acceleration, we would expect the speed at time 0 to be the same as the speed at time 6. But because the speeds are changing as time elapses, there must be some kind of acceleration. So we could answer that directly by looking at it. Yeah, there's acceleration, and the rate of acceleration seems to be increasing as time goes by. If we want to estimate the acceleration, we can make a crude guess of the average acceleration of taking the endpoint, because that will give us a change in speed, and the time over which that occurred, a change in time, and we can approximate the average acceleration. So if our vehicle was to follow the red path in the space-time continuum, it would get to this speed at 6 time units, or it could follow the blue path. The blue path is just an average acceleration approach. And we're going to revisit this later. And we have an average acceleration of 7.6 meters per second squared. Let's see if that makes sense. So we went from 40 meters per second to 0. So we gained 40 meters per second over 6 some odd seconds. So 40 divided by 6. Well, 6 times 7 is 42. So somewhere around 7 meters per second squared. So our average seems right. Okay, let's move to the next one. Scatter plots. Scatter plot, also called scatter plot, scatter graph, scattergram, scatter diagram, scatter chart, is a type of plot or diagram that uses Cartesian coordinates to display values, typically for 2 variables in a set of data, but we can use more than 2. If the points are coded, either by color, shape, and size, we can squeeze a third axis out of them. The data are normally displayed as a collection of points, each having a value of one variable determining the position on the horizontal axis, and the value of the other variable determining the position on the vertical axis. So it's really just an XY coordinate plot. It can be used when there's one continuous variable under control of the experimenter, and the other variable is independent. In the modern parlance, that's the response and the explanatory variables. If there's a parameter exists that's systematically incremented or decremented by the other, that's called a control parameter, and that can be plotted on the horizontal axis. There's another way to do these, which is to do something called a parametric plot. And the hopeless romantic curve that Farhang showed you back in the functions lab used a parametric equation. The parameter in his was t, and then t was used to generate x-y coordinates of the heart shape. Scatter plots are used to explore correlations between variables, and we'll get to confidence intervals later in the class, so we won't do anything on that today. But correlations might be positive, negative, or uncorrelated. So if the pattern of dots slopes from the lower left to the upper right, that indicates a positive correlation between the two variables. If it goes the other direction, negative correlation. And if the pattern of dots mostly looks horizontal, or even if it just becomes a blob in one location, there's no correlation. I guess blob in one location is perfect correlation of one type. A line of best fit, sometimes called a trend line, can be drawn in order to help examine the relationship between the variables. And an equation for correlation can be determined by established best fit procedures. For linear correlation, the best fit procedure is called linear regression, and we're going to look at several different ways to do that. And it's guaranteed to produce a solution. The word correct is incorrect. A solution. See, that's the way to do a lesson. You change it right there on the fly in finite time. There is no universal best fit procedure actually for anything. But arbitrary relationships are even harder. So if there's certain kinds of nonlinearities, oh, there's where that noise is coming from. Get the sound down. The scatter plot is also useful when we want to see how two comparable data sets agree and to show nonlinear relationships between variables. And much of what's above there you can learn more at Wikipedia on scatter plot. To learn how to make a scatter plot, Matplotlib.org or pyplot.org. Scatter plot in the search, and you get a lot of things. So here we're going to look at a set of data. I'm going to risk crashing the computer. So this is data of the heights in. Those got to be inches because that's too short for centimeters. Inches of father, mother, and the column's labeled son, but they have to be offspring because there's hundreds of these, and in hundreds of observations, it's likely that somebody had a daughter. So I have modified my example a little bit. So we're going to read that data, just like we learned last time in the pandas lesson, into a data frame called DF because we have no originality whatsoever. Then we're going to assign the column son to a new column called child, and then we're going to drop son in place using axis equals 1, exactly like Farang showed you in the lab. And go ahead and let's look at our first few rows of our database. So father, mother, child. There, that seems less offensive to me. Although it probably is a son just based on the heights. And then we need to make some lists because we're going to do plotting. So we're going to make a list called daddy, mommy, baby. And we'll put it together into a plot object called my family. Let's go ahead and build the lists. And again, from the class figure, and I made it 10 by 10, so this is going to make it square. And the type of plot we want to do is a scatter plot, and we want to plot baby on the horizontal axis, daddy on the vertical axis, and we'll plot it in red. So this is just going to be a bunch of red points. So let's see what the points are going to be telling us. It's going to be the height of either series in inches. So the horizontal axis will tell us what the baby's height is, and the vertical will tell us what the corresponding daddy height is. Run it, and there is our scatter plot. So let me ask you all a question. Is there any correlation indicated by this scatter plot? Positive correlation, positive, a very weak positive. Okay, you got the right idea. Yeah, it's going from, it's kind of sloping from lower left to upper right. The taller fathers tend to produce taller children, although it's not always the case. There are some tall children from short fathers, and there are actually almost no short children from tall fathers. So definitely there is a correlation of father's height to child's height. And that kind of makes sense based on our daily life experience. So if we were growing people like we grow farm stock, if we needed to select for height, we would choose taller fathers and mothers to produce taller offsprings, and somehow the National Basketball Association would be involved in that eugenics process. No, just kidding. The nature of business would tend to select for that, but you need to do millions and millions of pairs. So this plot, in my opinion, looks lousy. Let's see what makes it look lousy. We don't have any labels on the X and Y axis. A legend might be handy, and we probably should have a title. We'll leave the title off, but let's see if we can clean it up. And let's also include the mother information on it. So we'll plot the moms in blue, and we'll see what we can learn from that. When we do that, some things kind of appear from the scatter plot. The first thing is that the mothers on average are shorter than the fathers. Not a surprise there, although there are some tall moms. And secondly, do we see a correlation in the mother versus child height? That'd be a yes. There's a positive correlation between child's height and mother's height. So as a secondary predictor of child's height, can you make the axis have the same value? Probably. And so, Ileana, how would you find out how to do that other than asking me? Because I'm going to be evasive. Yay! Google! Excellent. There you go. Yes, so Ileana, I imagine there are plot parameters that would go into the into this part, into when you're actually calling the plot, where you can specify the lower and upper value of the axis, either as range of data or as explicit values. In fact, I know you can do that because you can do it in R. If you can do it in R, you can do it in Python, because Python's a copy of R. All right, well, so there's our scatter plot of the two things. The other thing I want to point your attention to, although this is coming later in the semester, if we were to use something called a classifier, so it's a technique that's common in what we call machine learning or narrow domain artificial intelligence. A classifier could probably identify with good reliability of the father from the mother in a plot like this, but there'd be a lot of misclassifications. This is part of why letting the FBI have computers to decide who's a criminal is a dangerous thing. If the red blob were way over here and the blue blob were way down here, and there was easily a line that you could draw between them, that would be a good candidate for a classification scheme. These data are not a good candidate for classification. Hopefully I'll remember that, and we'll try it when we get to that point in the class, and we'll demonstrate misclassification, because it just dawned on me to be a good example for that. So now let's repeat this same example using pandas. See, in pandas, there's a little bit less typing involved. So what we're going to do is, the data frame is already built, so we don't have anything to do there. We're going to invoke the scatter plot from pandas. First we'll do it just for the child and father. Then we'll create an object called ax, and we'll produce a scatter plot for child and father. And then we will produce another scatter plot, child and mother, and then we're going to put it onto the ax object. And then finally we will decorate it with labels and then render it. And there's the same thing done in pandas. And I don't know what I was doing there. Oh. So here's a good fix-it test. I'll scroll down here to the bottom, and I ask you all, what is wrong with the script? Because I thought it should work. I have a single mistake. Anybody, can you identify it? Google it.
Child.
Yeah, Brandon, this in this case, Google would not have helped. Actually, Google might have helped. If I Googled key error, it would come back and saying, you're an idiot, you have something typed wrong. If we change that to child, I think this will render correctly. Yay! All right, that's all I had for lesson 9 prearranged, but let's go ahead and add some content. How much time? I got a few minutes, actually 2, but I lost some time up front, so I'll take advantage of it. So we did box plots, we did lines, we did scatters. Last one is histograms. And who knows what a histogram is? Well, you know what? I don't, but I have a tool. Go to Google. And Khan Academy would be a really good thing to copy from, but I'm actually looking for something. There we go. I'm going to go to Wikipedia, because it's Creative Commons, and I'm going to say, yeah, okay, let me copy this and we'll edit whatever we want. And this is how your labs are built. Not every day you get to see your textbook built right before your very eyes. And the reason I'm taking care of the footnotes is I haven't figured out in Jupyter Lab how to preserve footnotes. I don't even try. Those look like hyperlinks. I guess I could just do that. You know, obviously, what I've just done right there is stealing. So I'm going to go ahead and take the URL. That's an attempted attribution. I guess I should put quote signs around it. Render it. There's our histogram narrative. And then I would go back and edit out, because some of the sentences are not particularly relevant. Let's look at how we would build a histogram. So we're going to use a database which has movies by title, studio, how much money they grossed, how much money was adjusted after Hollywood accountants made them lose money so that they didn't have to pay taxes, and what year it was produced. So let's look at this before we actually run it. We have the pandas subsystem already loaded. We're just going to do it again. And then we're going to read from a file called Top Movies. This is a big file. I'm not going to attempt to open it directly. And actually, I guess I can try something different. So I'm going to go ahead and try to look at the movie in the file. Yeah, it's just a big long file. So it's going to read the file as a CSV, and then we'll look at the first few rows, and there we have it. If we want to make a histogram of gross receipts, in the pandas tool there is a method called hist, which generates a histogram, and I'll describe the histogram once it renders, and we're going to build the histogram on gross. So what a histogram does is it identifies ranges of values. Those are called bins. And so the first bin in this one is going from 0 to, I guess it looks like just a little bit shy of 1 million units. 10 to the 8th, 1 billion units. And then, hundreds of millions. So it's in hundreds of millions. So 0 to the first $100 million, 100 million to the second $100 million, 200 million to 300 million, 300 million to 400 million, and so on. It's not exactly at the 100 million breakpoint, but this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins. And so it's producing a graphical approximation of the underlying distribution in a probabilistic and statistical sense of the data contained in the series named gross. We can also modify our histograms by adjusting the bin count So if we do 4 bins, we would expect one bin to go 0 to 2, second bin 2 to 4, third bin 4 to 6, and the fourth bin 6 to and up. And so I'm not off in my thinking. If we do 5 bins, okay, so it's the same data. We haven't changed data. It's the same object, a histogram, but by adjusting the bin count, the resolution of information contained in this histogram changes. Since I've been doing stuff I regret all morning, let's go ahead and really bump up the bin count. But yeah, well, I'll just do it without thinking about it. I really want to know what the total number of objects is before I do this. So now there's a histogram with 25 bins. And so now we're starting to approach a bin count such that the information is rendered as a empirical distribution. So let me ask you all this. In terms of gross receipts, let me reduce my bin count to something a little bit more manageable. Let me do about 10. There we go. What is the most frequently observed gross receipt amount? So 2, 28. Okay, so the most frequent is somewhere between $1 and $200 million. So it's this bin. So you're all right. I was trying to get you to identify this second column. How many movies gross more than $10 million? None. Excellent. Let's do some simple statistics on that and see what we can learn on that. I believe it's data frame. I'll just do it on the gross. Is that going to work? No, it's not. I'll just run the general describe function and do it by eye. So if we look at this information, we concluded that the most frequent was somewhere between 1 and 2. That would be erroneously akin to the median, which is around 2. The average movie produced $220 million, with a standard deviation of $144 million. It's pretty good money if you can make it. The lowest grossing movie was just shy of $100 million. Just shy of $10 million. And the biggest one was $900 million. And the biggest one occurred in 2015. The smallest one was in 1921, assuming that year is correct. I'd be curious what the smallest movie is in this case. So that's our introduction into histograms. All we want to do today is literally show you the code to generate them. Histograms can be a very powerful exploratory data guideline tool. And the Python, the plot library or pandas makes it fast to generate histograms. Keep in mind when we get to it more detail, there's more than just a bin count that you can include. I'm going to go with 100 bins just for fun. Oh, it can do 100 bins. So now it's starting to look more and more like a probability distribution. And you can see there's some peaks, and then the high grossing movies, there's not that many of them. So if you were going to your financiers trying to hustle them money, and you wanted this much, they could look at this and say, well, most of the stuff comes out here, so we're only going to give you this much, this 2. Not, you have to go somewhere else for the other 6 million. Okay, I think that's a good segue to start for the lab. Let me save that. Let me verify that we can still get to that. Yeah, it looks like the link is still working. And the lab link, if you go into the Doodle Miner here, that takes you directly to the lab. The alternative is if you can get this stupid bar out of the way. In the actual Lab 9 assignment, there should also be a direct link to the same place. Good, that's working. So I'm going to hand this off to Farang in a second. Farang, let me get all logged out of this server so that it works for you.
Sure. Are we going to go with a 5-minute break?
Yeah, we're doing it right now. So 5 minutes.
Okay.
So that's saved. Get those changes.
So we will start at 9:35, but if you have any